Hey guys, so I wanted to give you a short little lecture on distance, displacement, speed, and velocity. So these are the first four quantities we're going to learn about motion. And motion, in one-dimensional motion, so motion along a line, will form the first unit for AP Physics 1 for us. So I wanted to I'm sure you guys have ideas of what these terms mean. I just want to make sure we're all on the same page with them and make sure that we're all meaning the same thing when we talk. And also, I want to show you some cool mathematical relationships and some graphical relationships that'll be useful to you as we go through this course. So, distance, it's the essentially it's the change of position that an object undergoes. So we'll define position. We can define it anywhere we want. So back. Okay. All right, that's what I'm looking for. All right, so we can define distance as the change of position of an object. So I could have maybe a cool little car right here. Okay. And it's traveling along a road and it's going to end up, right here. And wow, it's not even like the same car. So as it's traveling, it's undergoing a change in position. So we're going to call this change in position, usually I'm going to call that delta x. I think the x comes from, the x-axis on the Cartesian coordinate system. But this delta x, when you'll see that in the equation, will symbolize a change in position. Okay, and so this change in position is what we call distance. Now, if we look at another case, so this is nice and everything's in a nice straight line, the delta x is very obvious. But if we look at maybe another situation, so maybe instead of having nice straight lines, maybe it's gotten larger. Maybe I start off at some city right there. And one of the cool things about physics is we can define our coordinate system. So I can decide that where I start, I'm going to make that position 0. And then I'm going to travel. Maybe I'm going to go up this way and then do a little loop-de-loop and then travel over here and then another loop-de-loop because I like loop-de-loops. Another one right here, and I'm going to end up right there. Okay. Now, the distance that I would have traveled will be the total change position that's occurred along this whole line here. Okay, so if I measured this total change in position as I travel along this line, then I would get the distance. Okay, and it's going to be fairly large. Now, displacement. Displacement is something different. Displacement depends on only my initial and my final position. So displacement has a more specific term. If this is my starting point, I'm going to say that that's x initial. And for initial, a lot of times in physics, we put I'm going to call that naught. It's like a little 0. So that's going to be my starting position. And then my ending position, my final position, will be right there. The displacement that has occurred, I get a new color here with green. The displacement that occurs goes from my initial position to my final position. Okay, now here's the thing. We're going to talk a lot more about this later, but displacement is this distance. Okay, it's that change of position. And we're going to put a little arrow above this. Now, the reason why we put a little arrow above it is because this is what's called a vector. Okay, we are going to use vectors so much in this course. It's a very useful mathematical construct. Essentially, a vector is a quantity like displacement that in order to describe it completely, I need to tell you how big it is, and we call that the magnitude. I also need to tell you what direction it's going in relative to some location. And so we're going to run into a lot of vector quantities. Displacement's one, velocity will be another one, force is one, momentum's one. We're going to run into a lot of these. And so later on, within the next couple of weeks, we're going to learn about how to add and subtract vectors, how to do arithmetic with them. But for right now, just become familiar with the idea of what a vector is. It's a quantity that in order to describe it, you need to have both how big it is and what direction it's pointing in. Okay, and that's what displacement is. Displacement's a vector, and it only depends on where you start and where you end. In fact, if I would have ended where I started at, my displacement would have been 0. Okay, I would have traveled a long distance, but my displacement would have been 0. All right. So we have this whole idea of a change position and displacement with a change in the position in a certain direction. Now, one of the first questions we ask is, okay, fine, you changed position. How quickly did you do that? In other words, what's the rate? Okay, when we talk about rates, we talk about something divided by time. So when we talk about speed, the speed of an object, that's going to be the total distance covered. Okay, so total distance covered. So we're talking about distance again. Divided by the time that you need it to cover that distance. Okay, and I guess technically speaking, this would be the average speed. Okay, because you can imagine you go faster, you can go slower, but if you take some total distance and divide it by the time, then you'll get what we call the speed. Okay. Now, velocity is tied to displacement. So we'll represent velocity with a V, and we'll put another little arrow over it because it's a vector as well. Velocity looks a lot like speed, except it's the displacement. I'm going to use delta x here. So it's the displacement, which is a vector over time. So that means velocity is a vector too, and velocity points in the same direction that the displacement does. Okay, it points in the same direction as that displacement. A word about units here. You know, we measure a lot of quantities in physics. So a word about the units that we use. The ones that we're going to use now. So we use length. Okay, so we need some unit of length. Now in physics, all of our calculations have got to be done so that our length is in meters. Do not forget that. Evil physics teachers will give you quantities in centimeters or kilometers or, heaven forbid, miles or something. You need to convert those back to meters. Okay, and the unit of time that we will use will be in seconds. These are called the SI units. These are the accepted standard units of measurement. Oh, damn, just skip ahead there. Okay, these are the standard units of measurement. Okay, for length and time, so make sure that you guys use them. And right here, with the velocity equation, we have a nice little relationship. Okay, so I'm going to use red to put a little square around that. You guys really want to make sure you get these definitions in your notes. But you can see how I could rearrange that fairly easily. And I could also solve for the displacement if I know what the velocity is and if I know how much time has passed. Okay, so we can rearrange that. And this is another useful equation that we're going to have. Okay, so these two equations, velocity is equal to change in displacement over time, and then displacement is velocity times time. These are going to be true, okay, when velocity is constant. Now, we're going to let the velocity change. That's kind of like the next step in this whole process. But for right now, our velocities are going to be constant. And so we're going to be using these two equations to start off with. Okay. Now, finally, just to wrap this up, I want to show you kind of a cool graphical relation that you can get. If you were to plot position versus time, okay, and you get a graph, and you get a graph that looks like this, what you're going to notice is that the change in position over the change in time is constant. Okay, so it changes over that much time, it changes by that much. Okay, let's start here. By this much time, it changes by that much. The change in position and the change in time will be equal at every single time interval. So for a constant velocity motion, when we're moving at a constant velocity, or in this case a constant speed because it's only one dimension, we're moving at a constant velocity or constant speed, we'll have a position versus time graph that's a straight line. Okay, if we're at rest, it's going to be horizontal. If we're moving at constant velocity, it's going to be a diagonal. Okay. So that's that. And the cool thing about this is that if we realize that this is my change in time and that this is my change in position, then the slope of this graph is change in position over change in time. So the slope is equal to the velocity. Wow, that really flew up there. The slope is equal to the velocity, okay, or the speed in this case. Okay, so I'm going to just put velocity down here. And how cool is that? So you can actually use a graph to obtain the velocity of an object if it's a position versus time graph, and if you find out the slope. Okay, the slope of that graph would be your velocity. The other thing that I want to point out to you guys is that there's a sign to this as well. Okay, so because of that, I'm going to back up one here. So just bear with me. Okay, this change in position over change in time. Absolutely true. But what if, erase all this. Let's go back to our straight line motion. And let's imagine that we're going to start right there. Okay, and we're going to start moving in this direction. And then another object, I'm going to displace it, another object starts right there, and it's going to move in that direction. Okay. Whenever we work these problems, even though it's just along a straight line, we have to define what our positive direction is going to be, and that's up to us. Typically, I make to the right positive, and I indicate that, I draw a little arrow with positive. So that means that this change position is going to be a positive change in position, and this change in position is going to be a negative change in position. And it means that this velocity would be negative, and it also means that this velocity, let me go back, and it means that this velocity would be positive. So when you guys are doing physics problems or you're analyzing physics experiments, make sure you keep track of your coordinate system. It is so easy to forget to do that. You know, you think you got it, think it's really straightforward, but you have to realize that if things are traveling in opposite directions, you're going to have to make one positive, make the quantities positive for one, and make the quantities negative for the other. All right, so that's what I want to tell you guys about one-dimensional motion, velocity, speed, displacement, distance, and I hope it helped. And if you have any questions, feel free to ask me in class.